In this video, I'll be covering question 4, part D from the 2012 AP Calculus AB free response no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. Alright, so part D here is asking us to find the value of this definite integral. So we're being asked to find the integral from 0 to 5 of x times the square root of 25 minus x squared dx. When we look down at the page and you see that you've got something more than just a bunch of stuff being added and subtracted, and it's not one of what I just call special case antiderivatives, things you just have to have memorized, your trig functions, natural logs, e to the x's, those types of things. Really, the only other game in town with integrals is going to be U-substitution. And so that's what I would be doing here, is we would be going through a U-substitution process. Before you begin that, though, remember that when you first look down at an integral or a derivative problem, you want to be on the lookout for a handful of rewrites. And the rewrite that we're looking out for on this problem is whenever you've got a root in a problem, x to some power inside a root, we would rewrite that as x to the power divided by the root. So if you had something like the cube root of x to the fifth, you'd rewrite that as x to the power of 5 over the root of 3. So on our problem here, all that stuff on the inside is to the first power, and then that's a square root. So before we even dive into our U-substitution, we would rewrite this as x, and then this would be 25 minus x squared to the power of 1 over the root of 2 dx. So that's just a rewrite only. And now we start running through our U-substitution process. Step 1 of the U-substitution process is we need to choose the U. When I go to choose my U, I've got sort of a priority list that I run myself through. The first thing I go looking for, if it's available to me, is a natural log if it's in there. If I don't see a natural log, then I go looking for what I call the inside piece, as if I was doing a chain rule problem, something inside a set of parentheses. If I don't see that there, then I go looking for the bottom of a fraction. Working our way through this list, there's no natural log, so that wouldn't be what I'm looking for. I do have an inside piece. This 25 minus x squared is inside that 1/2 power. That will then be my u. So I set this up, 25 minus x squared is my u. Step 2 of the process is always the same. You're now going to take the derivative of that. So du dx. Always use that differential notation. Du dx, du, d, whatever your other variable is. Now we'll take the derivative of u like a normal derivative. The derivative of 25 is a constant. That would go away. The derivative of negative x squared, that's a power rule. I bring the 2 down in front. That's going to get me negative 2, and then x to the first when I subtract 1 from my power. Step 3 of the process is always the same here. So step 3 of our process is we would come through, and we need to change over the language of this full integral to talking the language of u, and that includes turning that dx into a du. And so what you're going to do now is you're going to come through and you're going to resolve this equation to get dx by itself. So I'm going to multiply both sides by dx. The dx on the left will cancel out. We'll get du equals negative 2x dx, and then we'll divide by negative 2x. Divide by negative 2x, and we end up with du over negative 2x equals dx. This part of the process is different than the way most people's teachers teach them, but it will make finding this U substitution so much easier, because now we can just replace that dx with what it's equal to. On most U substitution problems, we'd be done at that point. But we have bounds on here. And again, we need to change this whole problem over to talking the language of u, and those are x values. So to go through the rest of this, step 3 would have been finding our du dx piece, and then step 4 here is now going to be to adjust the bounds. To adjust our bounds, you'll take your u equation from up above. So u is equal to 25 minus x squared, and we're going to plug in these x values. So on the top, when x is equal to 5, I plug in 5 into this, and I get 25 minus and then plugging in 5 for x would be 25 minus 25, so that gives me a u value of 0. My lower bound, x equals 0, I plug into my u equation. This is 25 minus 0 squared, so out of there I get 25. Now I'm ready to go do the substitution part. I'm going to take and I'm going to substitute in my u, I'm going to substitute in for my dx, and I'm going to substitute in my bounds into this integral. So you just work your way through this integral left to right, and it's either one of the things we substitute in for, or it gets left alone for the time being. Starting with my bounds, my new lower bound, 0, is now going to become 25. My new upper bound is going to become 0. Nothing happened to this x, so it's going to stay there. Now I'm going to plug in my u. That's going to make this u to the 1/2. And now dx is going to be du over negative 2x. If we've done everything properly, then any x's that were left in the problem should cancel out with x's we just plugged in. So sure enough, that x is going to cancel with that x. And now we're going to rearrange what we have. So we're looking at 25 to 0. There's an unwritten 1 right there, so this is a negative 1/2 that I'm going to slide to the front, u to the 1/2 du. This is now what I call your reward for all of your hard work. You have a brand new math problem. What we've ideally done is taken our starting antiderivative, our starting integral that we couldn't handle, and turned it into something we could. So this is either going to be a power rule or a special case. Because it's a brand new math problem, we have to take a look at it first and make sure it's set up properly. And what we'll notice is that our lower bound and our upper bound are not in the proper order. You always need that lower bound to be the smaller value. So to flip those bounds, you do what I call pulling a negative. I don't know if that's the proper math term for it, but it's what helps me remember. So I pull a negative to the front, and that's now going to flip my bounds. The lower limit will now be 0, the upper limit will be 25, and then the rest of the stuff inside here stays the same. From here, I'm looking at a straight up power rule. So I'm now going to apply my power rule for antiderivatives. The power rule for antiderivatives, step 1 says add 1 to the power, and then step 2 is going to be to divide by the new power. So we'll add 1 to our power. We're going to end up with negative 1/2. Adding 1 to the power gets us u to the 3/2. And then we divide by that new power, which is 3/2. Because we've got bounds on this, this is going to be evaluated from u equals 0 to u equals 25. And the one thing a lot of people forget on this is they forget this negative is out front here. So that negative is still out front as we come through this. From there, we now do what I just call top minus bottom. You're going to take that top value, plug it into this equation, and you're going to subtract off the bottom value plugged in. So plugging in our values now, again with our negative on the full outside of this, we would get negative 1/2. I would go ahead and flip this right here. That's going to be a 2/3 when we bring it up from the bottom to the top. And then plugging in for u, our top value, we get 25 to the 3/2. Then we'll subtract off of that. Again, we've got our negative 1/2 out in front. We've got our flipped 2/3 here. And then on the bottom, we're going to have u to the 3/2. The great news about half of this problem is it all goes away. 0 times all of this is just going to go to a big 0. Working our way through the front, we'll still have our negative sign from out front here. This 2 and that 2 are going to cancel out, so we'll have a negative 1/3. And then 25 to the 3/2, this is where you've got to basically undo this rewrite that we did here. So 25 to the 3/2 is really the square root of 25 and all of that to the 3rd. And when we bring that all together, the square root of 25 is 5 to the 3rd, and then 5 to the 3rd would be 125. So this will be times 125, technically over 1. Now multiplying all that, our negative is going to give us a positive, so we end up with 125 over 3, and that's going to end up being our final answer. So in the end here, we're going to get out basically 2 points from making it all the way through the antiderivative, through that full U-substitution process and getting out to here. That's going to get us 2 points, and then we're going to get 1 additional point for getting that answer right at the end. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.